Hello dear student. So this is unit last from chemistry paper third and semester 4. So statistical treatment of analytical data. So whenever we perform any experiment, we get the readings. Okay. So after getting the reading, we proceed for the calculation purpose, right? So that calculations comes under the statistical treatment of analytical data. So here in this topic, we are going to learn how to minimize or remove the error, how to minimize or remove the error which arises during the performing experiment or during the experiment. Okay, so we'll see here in this slide nature of indeterminate error, how indeterminate error arises during the experiment. Okay, so repeated measurements for a sample will provide identical results. Okay, when such a observation pile up, formation and accumulation of data begins. Okay, we take different or the number of readings, and that readings help us to generate the data. Okay, so in routine qualitative analysis, what we do, we take a number of reading. Okay, in chemistry laboratory, when you perform any practical, you take at least 3 readings. Okay, so you can take a number of readings. It is not necessary that you must take only the 3 reading. Okay, to get more and more accurate result of your experiment, you can take more than 3 readings. Okay, you can take 50 reading, 100 reading. Okay, that is for the getting more and more accurate result. Okay, and there are the different terms comes in the statistical treatment of analytical data. That terms we are going to learn here, and how that terms help us to get the more and more precise and accurate result that we are going to study here. So here we are going to see there are the measure of central tendency and dispersion. Central tendency म्हणजे आम्ही काय करतो की साधारणपणे जे टायट्रेशन आहे त्याच्यामध्ये आपण बघतो की तुमचे रिडिंग जे आहे ते 10च्या नीट आजूबाजूला येतात, बरोबर ना? जेव्हा आपण स्टँडर्डायझेशन करतो तेव्हा रिडिंग कुठे येतात? 10च्या आजूबाजूला येतात. पण 10च्या एकदम जवळ जे रिडिंग येतात त्या 10च्या भोवती जे रिडिंग येतात त्याला आपण सेंट्रल टेंडन्सी म्हणतो. मीन्स युअर रिडिंग आर ट्राय टू क्लस्टर ॲट ए सिंगल रिडिंग और नियर द सिंगल रिडिंग or about the single reading. But if your reading goes 11, 12, 13, or if your reading remains to the 9, 8, 7, in that case, that is called a dispersion. Okay, because your reading are not coming nearby the 10. Okay, so if reading is getting much deviated from the 10 in the case of standardization in your laboratory, that you may say as a dispersion. So what measures are there for the central tendency? What measures are there for the dispersion? Okay, and that we are going to see over here. Now see. The central tendency for a set of observation indicates the tendency of observation to cluster around a central value, जे की मी 10 बोललो होतो तुम्हाला. And spread of set of observation indicates distribution, right? That is a dispersion. Now we'll see the measures of central tendency. कुठले कुठले आहे measures? पहिला आहे arithmetic mean. मी 15 रिडिंग घेतल्या, 15 रिडिंग ज्या आहेत है ना, त्या 15 रिडिंग घेतलेल्या आहेत त्यांची बेरीज करायची आहे अपॉन 15. जे तुम्ही ऍव्हरेज घेतात ना किंवा मीन घेतात ना, दॅट इज व्हॉट द अरिथमेटिक मीन. ओके, सो xi bar x bar is equal to summation of xi, where I goes from 1 to n upon n. N are the number of readings. Okay, in this way you can take arithmetic mean and you can take a median. What is a median? When the observations are arranged in the ascending order of their magnitude, central value, if the observations are odd in number, and then the mean of central pair, then they are called as a median. म्हणजे इथे बघा किती reading आहेत? 5 reading आहे. 1, 2, 3, 4, 5. So this is called a median. आणि जर इथे 6 व्हॅल्यू असतील 1, 2, 3, 4, 5 आणि 6, या सेंट्रलच्या ज्या 2 व्हॅल्यू ना यांची बेरीज करायची आणि त्याची मीन घ्यायची. That is called median. Okay. Now what is a mode? What is a mode? It is defined as the observation that repeat itself maximum number of times. If the observation is not repeated, the set will have no mode. Okay. On the other hand, if the same maximum frequency of occurrence is observed for the two observation, then the both will comes as a mode. आता इथे 10.2 2 वेळेस आलेला आहे, 10.8 2 वेळेस आलेला आहे या सेट मध्ये. This is what? This is called as a mode. This is called as a mode. जर रीडिंग रिपीट झाले नसते तर तिथे मोड नसतो. ओके. नाउ ऑफ डिस्पर्शन है ना, की ऍब्सोल्यूट डेविएशन जे आहे है ना, तुमची जी रीडिंग आहे कुठली एक रीडिंग असेल है ना, तिच्यातला आणि तुमच्या ऍव्हरेज मधला जो डिफरन्स आहे त्याला काय म्हणतो आपण? डेविएशन. कुठली तरी एक रीडिंग आहे तिची व्हॅल्यू आणि जी ऍव्हरेज काढली आहे तुम्ही, कुठे ऍव्हरेज काढली आहे? या ठिकाणी इथे ऍव्हरेज घेतली, बरोबर ना? याचा जो डिफरन्स आहे, सो दॅट रीडिंग मायनस दिस ऍव्हरेज इज कॉल्ड एज ए dispersion. What is a relative or deviation? You can say absolute deviation. What is relative deviation? So this deviation upon mean. Okay, this value upon mean. What is mean? That is x bar. That is a relative deviation. Okay, what is average deviation? So sum of all deviation upon n. N are the numerical value. Okay, so number of deviation. N is the number of deviation. Let me calculate. So d bar is equal to summation of di upon en. What is the relative average deviation? It says, d bar, average deviation upon x bar. That is average. Okay, that is average. जी की तुम्ही इथे कॅल्क्युलेट केलेली आहे. Okay, d bar upon x bar is equal to relative average deviation. Okay, if you multiply by 100, that will become part per 100. If you multiply by 1000, then relative average deviation comes as a part per 1000. If you multiply by million, that will comes a relative average deviation in part per million. Okay, but it is usually expressed as a part per 100, part per 1000. Now, measure of dispersion for a set of observation. आता इथे काय आहे? For a set of observation आहे. इथे काय होतं? Measure of dispersion. Okay, इथे set of observation नव्हता. Getting my point? Now here we are taking set of observation in that range. Okay, maximum value of x minus minimum value of x means maximum reading ची व्हॅल्यू असेल, reading ची maximum value आणि reading ची minimum value जी आहे है ना, समजा तुमचा 11 आली मॅक्सिमम आणि मिनिमम 9 आली, रेंज किती येईल? 2. त्याच्यानंतर स्टँडर्ड डेविएशन, द स्क्वेअर रूट ऑफ मीन ऑफ स्क्वेअर्स ऑफ इंडिव्हिज्युअल डेविएशन है ना, स्क्वेअर रूट ऑफ व्हाट? मीन ऑफ squares of individual deviation. Now see, square deviation is equal to square root of then mean of, कसली मीन घेतली? मीन ऑफ स्क्वेअर्स ऑफ इंडिव्हिज्युअल डेविएशन. हे इंडिव्हिज्युअल डेविएशन काढायचं, याची स्क्वेअर घ्यायची इंडिव्हिज्युअल डेविएशन. ओके, डिवाइडेड बाय n minus 1. That n is where n is less than 20. म्हणजे रीडिंग हे 20 पेक्षा कमी असतील घेतलेले, 20 पेक्षा कमी रीडिंग घेतले नंबर ऑफ रीडिंग, तर n मायनस 1 असेल. बट रीडिंग हे जर 20 पेक्षा जास्त घेतले है ना, रीडिंग जर 20 पेक्षा जास्त रीडिंग घेतले तर हा काय असेल? n असेल. and that is indicated by sigma. Okay, this is indicated by s. Okay, what is variance? Variance is a square of standard deviation. What is the coefficient of variance? Variation. So coefficient of variation is a, yes, that is standard deviation upon d bar into 100. Standard deviation upon d bar into 100. d bar कुठे कॅल्क्युलेट केलेला आहे तुम्ही? त्या ठिकाणी d bar कॅल्क्युलेट करता. Okay, so that is what coefficient of variation. Okay, now we'll see distribution of random error. Distribution of random error. Random or indeterminate error exist in every measurement. So these are the error which are present in every measurement. Okay, so mathematically the relationship which best satisfies such a distribution of random error is known as a normal or Gaussian distribution. Is known as a normal or Gaussian distribution, and this is a bell-shaped curve symmetrical about the mean. Okay, so see, this is what the Gaussian distribution curve. Let me show you. Okay, this is Gaussian distribution curve. याचा काय फक्त स्प्रेड वाढतो इथे. बघा, सुरुवातीला कसा आहे इथे नॅरो दिसतोय जरा, है ना, बट या केस मध्ये काय झालाय तो, बघा कसा स्प्रेड झालाय या ठिकाणी, है ना. नाव see now Gaussian distribution curve for a large number of replicate measurement or reading free of determinate error, that is free of determinate error, but there is a presence of indeterminate error. Okay, the result will generally be symmetrically distributed around the mean. By determining the relative frequency of occurrence of the reading and plotting the values for different results, the curve obtained is known as a normal distribution curve. By determining the relative frequency of occurrence of the reading and plotting the value for different results, the curve obtained is called as a normal distribution curve. The curve satisfies the equation. Which equation? That is given by Gauss and Laplace. That is given by Gauss and Laplace. Okay. Hence, the distribution curve is also called as a Gaussian distribution curve, or normal error curve. That gives us the indeterminate error. Okay, so y is equal to 1 upon sigma square root of 2 pi exponential of x min or e raised to minus xi minus mu bracket square upon 2 sigma square. Okay, this is what the Gauss Laplace equation. Okay, equation of curve, that is the equation again we are taking here. So what is y? It's a relative frequency of occurrence for a given set of observation. Then xi is a value of corresponding observation for a set. Mu is a mean of population or the universe with infinite number of observation. This is for the infinite number of observation. Sigma is a standard deviation for population or infinite number of observation. Okay, for the infinite number of observation. So graphical representation of the curve. So method 1, where what we are taking, so y is the frequency of occurrence and here is a xi, that is a individual observation, you can say. Okay, now second method is relative frequency of observation on y-axis and on x-axis xi minus mu, that is a deviation from the population mean. Deviation from the population mean. Third, what is on the y-axis there is a relative frequency of occurrence. Okay, on x-axis there is a standard deviation. Okay, we can see here relative frequency of occurrence on the x-axis. Here it's xi, here it is a di, and here it is a sigma. Okay, see here the value of sigma, to this side there are positive value, to this side there are negative value. Here is again same, to this side there are the negative value. Okay, so A, B, and C are the three different ways to indicate the Gaussian distribution curve. Indicate the Gaussian distribution curve. तर त्या ठिकाणी परीक्षेमध्ये विचारतात Gaussian distribution curve वरती क्वेश्चन. ओके, त्यावेळेस काय करायचं, आपल्याला इक्वेशन द्यायचं आहे, त्यानंतर त्याच्या सिग्निफिकन्स द्यायचा आहे इक्वेशनचा, त्यानंतर काय करायचं आपल्याला, इन हाऊ मेनी मेथड्स वी कॅन represent the Gaussian distribution curve. Okay, so what are the characteristics of Gaussian distribution curve? This is what equation y is equal to 1 upon sigma square root of 2 pi exponential raised to minus xi minus mu bracket square upon 2 sigma square, right? So, the curve is symmetrical about the central value, that is a population mean. That is a population mean. That is a mu. This is a population mean. ओके. आणि जी आपली प्लेन जी मीन दाखवली होती ती कशी दाखवली होती आपण सिग्मा बार. हे नंबर जेव्हा लार्ज नंबर ऑफ रीडिंग असतात तेव्हा हा एक्स बार जो आहे तो याच्याने इंडिकेट करणार आहोत. Okay, so that concept will be clear to you in the later slides. A salient feature of curve: as the magnitude of deviation of either sign increases, the probability of its occurrence decreases. As the magnitude of deviation of either sign increases, the probability of its occurrence increases. The total area under the curve covering all possible values of xi from minus to plus will thus represent the population. The total area under the curve indicates the population. Okay, that indicates plus to minus value of xi. Every observation, irrespective of magnitude, has a definite probability of occurrence. Every observation has a definite probability of occurrence. The area bound by the curve, the x-axis and the ordinate x is equal to x1 and x is equal to x2 represents the fraction of total population between x1 and x2. Total population between x1 and indicates total population between x1 and x2. Okay, the statistical properties of the curve. The width of the normal error curve is found to be dependent on the numerical value sigma. Okay, so the range आहे mu plus minus sigma will cover 68.3% of total population. Then mu plus minus 2 sigma will cover 95.5% population. Mu plus minus 3 sigma will cover 99.7% of population. Thus, practically, the range mu plus minus 3 sigma is sufficient to take care of the entire population. Okay, so now we'll see Gaussian distribution curve, accuracy and precision. Gaussian distribution curve, accuracy and precision. Okay, so this I will continue in the next lecture. Okay, this much is enough for